160 million years. This was the duration of the dinosaurs' reign over Earth. But do you know how long the extinction event actually took? The answer is chillingly short, a mere 3 years. From the apex of the food chain to total annihilation, it took only 3 years. What is even more disturbing is that the primary agent of destruction was not the asteroid itself, but rather the catastrophic aftermath of the impact 66 million years ago, when a celestial object with a diameter of 10 kilometers struck Earth at a velocity of 20 kilometers per second. One might assume the dinosaurs were killed instantly by the impact. This is incorrect. Those obliterated in the initial blast were arguably the most fortunate. So what did the surviving dinosaurs experience? Why did crocodiles and turtles survive, while the dinosaurs faced total extinction? First, let us examine the mechanics of the impact event. The instant the asteroid made contact with Earth, the energy released was equivalent to the simultaneous detonation of 10 billion Hiroshima atomic bombs. To put this magnitude into perspective, the most powerful nuclear weapon in human history, the Tsar Bomba, is as insignificant as a firecracker by comparison. Seawater at the impact site evaporated instantly, not merely boiling, but undergoing immediate vaporization. The Earth's crust was torn apart like paper. A crater 30 kilometers deep formed within a single second. However, the catastrophic effects were just beginning. The volume of displaced rock was immense, a staggering 2 trillion tons. These rocks were ejected to an altitude of 160 kilometers. Then, in an incandescent state, they re-entered the atmosphere at temperatures exceeding 1,000 degrees. Imagine, a global rain of molten rock, lasting for several days. This explains the earlier assertion that instant death was a mercy, because the surviving dinosaurs were about to face a truly hellish environment. In the first few hours post-impact, the entire planet transformed into a thermal trap. NASA research data indicates that surface temperatures surged within mere hours, from 30 degrees to 300 degrees Celsius. Consider the implications. A standard domestic oven operates at around 200 degrees, yet the Earth at that time was significantly hotter than an oven. At these temperatures, trees did not burn slowly. They spontaneously combusted, as if doused in gasoline, with an explosive force. Everything ignited instantaneously. Dinosaurs situated thousands of kilometers from the impact zone may have perceived themselves as safe. They were gravely mistaken. In Mongolia, 13,000 kilometers from ground zero, the dinosaurs first felt the ground tremble from seismic waves. Then the sky began to darken, followed by a rapid spike in atmospheric temperature, 30 degrees, 50 degrees. At temperatures exceeding 90 degrees, dinosaur skin began to smoke, blister, and carbonize. They fled in panic, seeking any form of shelter or shade. But it was futile. The entire landscape was engulfed in flames. Some dinosaurs sought refuge in caves. Others submerged themselves in rivers. Did this ensure their survival? The respite was brief. The true nightmare was only beginning. When the rain of fire finally ceased, survivors might have thought the worst was over. Suffering from burns and starvation, they remained alive. But as they looked up, they were met with a terrifying reality. The sun had vanished. The 2 trillion tons of dust ejected by the impact completely obscured the sky. Simulation data from the Chinese Academy of Sciences suggests that this dust circulated in the atmosphere for a full 20 years. 20 years without sunlight had profound consequences. The Earth transitioned instantly from a furnace to a deep freeze. Global average temperatures plummeted by 15 degrees. Note that the ice ages were only 5 to 6 degrees colder than modern levels. This was a sudden drop of 15 degrees. Without sunlight, plants could not perform photosynthesis. A 2023 study published in the journal Nature confirmed that in the first 2 years post-impact, almost all plant growth on Earth ceased. Imagine this. Consider a scenario where all vegetation in your vicinity withers and dies, followed by 2 years of complete barrenness. What would this signify for the dinosaurs? The first to succumb were the massive herbivores. A triceratops required 500 kilograms of plant matter daily to survive. Looking across the landscape, only scorched earth remained. Unable to find a single green leaf, they resorted to stripping bark and consuming dried grass, or even scavenging the carcasses of their own kind. Yet, this was insufficient. For a 12-ton triceratops, a single day without food would induce severe physical weakness. After 3 days, they could no longer stand. The situation was even more dire for the long-necked sauropods, such as the Argentinosaurus. Weighing over 70 tons, they needed to consume a ton of foliage every day. With the vegetation gone, they were like massive engines deprived of fuel. Growing progressively weaker, they were forced to pause frequently for breath. Ultimately, these erstwhile giants collapsed one by one along their migratory routes, never to rise again. One might assume carnivorous dinosaurs could survive by scavenging these remains. That is a naive assumption. As an apex predator, the Tyrannosaurus rex required daily meat intake equivalent to 10% of its body weight, which amounted to approximately 600 kilograms. Initially, carrion was available, but the supply was finite. Within a month or two, 6 months at most, all edible resources were exhausted. The tyrannosaurs then turned to cannibalism. Statistical analysis of the fossil record indicates that this catastrophe caused the permanent extinction of 75% of Earth's species. However, behind this figure lies a more terrifying reality: the velocity of the extinction. Stratigraphic analysis reveals that the most intensive phase of extinction occurred within just 3 to 5 years of the impact. This implies that, in the span of a few short years, tens of thousands of lives were extinguished daily. The situation in the oceans was even more catastrophic. The impact caused the mass death of surface phytoplankton. Without phytoplankton, oxygen production ceased. Dissolved oxygen levels in the ocean dropped by 70% within a few months. The giant reptiles that ruled the seas, such as mosasaurs, plesiosaurs, and sea turtles, struggled and suffocated in the hypoxic waters. Their carcasses drifted on the surface, stretching for thousands of kilometers, a scene of unimaginable devastation. Yet, there is a peculiar anomaly here. Why did crocodiles survive? Why did even small mice survive, while the dinosaurs were completely annihilated? The answer lies in survival strategies. First, consider body size. The survivors shared a common trait. They were small. How small? Most mammals of that era were no larger than rats or rabbits. Small stature meant lower caloric requirements. A small mouse needed only a few grams of food daily to survive, whereas a Tyrannosaurus required 600 kilograms. Under conditions of extreme food scarcity, those with smaller appetites had a higher probability of survival. Second is the habitat. Why did crocodiles survive? Because they inhabited aquatic environments. Water changes temperature much slower than air. When land temperatures soared to 300 degrees, deep water remained at a survivable 40 or 50 degrees. Furthermore, crocodiles could go months without eating by lowering their metabolic rate. Turtles were even more resilient. They could enter a state of dormancy, reducing bodily functions to a minimum and surviving up to a year without sustenance. Another critical factor was diet. Scavengers and omnivores capable of eating insects or seeds had far higher survival rates than strict herbivores or carnivores. This was because they had access to a wider range of resources. The vegetation died off completely. However, some species survived by consuming insects. While large animal populations collapsed, scavengers persisted by feeding on seeds. But as for the dinosaurs, herbivores relied exclusively on plants, and carnivores relied solely on meat. Their dietary requirements were too specialized. Once the food chain fractured, their extinction was inevitable. In 2012, scientists in North Dakota, USA, discovered a stunning fossil site known as Tanis. Buried here are creatures that died on the very day of the impact, including a perfectly preserved dinosaur leg bone. Through microscopic analysis, researchers examined the marrow cavity of the leg bone and discovered glass spherules generated by the impact. What does this signify? This dinosaur died at the exact moment of the collision, and within its body, it preserved the most direct evidence of the catastrophe. Another discovery is even more heartbreaking. In the Gobi Desert of Mongolia, paleontologists discovered a clutch of fossilized dinosaur eggs. On the shells, there are scratch marks left by the mother protecting her young. CT scans revealed that the embryos inside were fully developed. They were just days away from hatching. But they lost that chance forever. In the darkness and freezing cold, they fossilized alongside their mother. Some dinosaurs survived longer. In Alberta, Canada, scientists found a hadrosaur fossil that likely survived for several months after the impact. Its ribs showed distinct signs of starvation. Yes, the bones reveal traces of severe malnutrition. In the final months of its life, this hadrosaur searched desperately for food every day. Eventually, emaciated and weak, it collapsed on a barren wasteland. 10 years after the impact, the atmospheric dust finally began to settle. Sunlight, like a key, unlocked the door to life once more. Ferns were the first to recover. Their spores can remain dormant underground for years, waiting for the right conditions to instantly germinate. Next came mosses, lichens, and shrubs. Greenery slowly began to reclaim the earth. Small mammals hiding in subterranean burrows could finally emerge to breathe. They cautiously poked their heads out to find a world completely transformed. With the dinosaurs gone, ecological niches across the planet were left vacant. What did this mean for mammals? Opportunity. Infinite opportunity. Over the next 60 million years, mammals underwent explosive evolutionary radiation. Some grew to massive sizes, evolving into elephants and rhinoceroses. Some took to the skies, evolving into bats. Some migrated into the oceans, becoming whales and dolphins. And one lineage evolved a larger brain, learned to walk upright, and mastered the use of tools. Eventually, they rose to the top of the food chain. That species is us, humans. At this point, we must confront a brutal reality. Dinosaurs dominated Earth for 160 million years. They were so evolutionarily successful and so powerful, yet they vanished completely in just a few years. And what of humans? We have existed for a mere 3 million years, yet we have drastically altered the planet. NASA data indicates that there are over 30,000 known near-Earth asteroids. Among them, more than 1,000 are classified as potentially hazardous objects. Although the probability of a short-term impact is low, low probability does not mean impossible. The dinosaurs 66 million years ago did not know an asteroid was coming. On an ordinary morning, they met the end of their species. But perhaps what we should be more vigilant about is not a visitor from outer space, but ourselves. A 2024 report from the Chinese Academy of Sciences states, over the past century, the rate of species extinction has reached 1,000 times the natural background rate. What does this imply? Humanity is driving an artificial mass extinction event with a destructive potential rivaling the asteroid itself. The dinosaurs' 160 million year reign serves as proof that even the most dominant species can be obliterated in an instant. What then of humanity? Will we succeed where the dinosaurs failed, or are we destined to repeat their fate?